guys, my name is Christina Flores, and for today's video, I am going to explain this following question. Keep watch because I am going to start. There are two stages of photosynthesis. The stage 1 is the light reaction solar energy, or also known as a light-dependent reaction. The second stage, or the stage 2, is the Calvin cycle chemical energy, or also known as light-independent reaction and dark reactions. The difference between the two, the light reaction or light-dependent reaction, this is the energy from the sunlight is to absorb by chlorophyll, and that energy is converted into stored chemical energy. On the other hand, the Calvin cycle or light-independent reactions, this is the chemical energy harvested during the light-independent reaction drives the assembly of sugar molecule from carbon dioxide. Therefore, even though light is not a reactant in the light-independent reactions, they still need the byproduct of light-dependent reactions. In order to work, however, light also activates a number of enzymes involved in the light-independent processes. Energy carriers are specific molecules that are used by the light-independent reactions to temporarily store energy. It is possible to think of the energy carriers that transfer energy from light-dependent process to light-independent reaction as being full. Because of how much energy they contain, the empty energy carries return to light-dependent process to receive further energy once the energy has been released. As we can see in the first picture box, it represents the photon, which is the yellow circle, the chlorophyll ground state, which is a blue circle inside the box. Then move to the second box where the photon explode into the chlorophyll ground states. For the third box, the circle become color green, which is chlorophyll excite state. Furthermore, this was called if chlorophyll absorbed as a photon of a particular energy, one of its electrons jumped to up an excited state. This chlorophyll molecule set inside of the photosystem with many other chlorophyll in its ground state or represented by the blue circle, and the excitation state represented by the yellow-green color circle. After absorbing photon, represented by a yellow circle, can get passed around from molecule to molecule, with one electron relaxing back to the ground state, emitting another photon that will excite an electron in another molecule, and so forth like a pinball machine. A photon may eventually strike the reaction center complex shown by the red circle that additionally includes two molecules of chlorophyll. Following that photon's impact on the reaction center complex, the high energy excited electron, rather than relaxing back to the ground state, instead excited electrons rather than relaxing back to the ground state, instead it will be transferred to another molecule known as the first electron acceptor or above the reaction center complex. After that, the enzyme provide the missing electron to the chlorophyll was oxidized by a water molecule to return it to its original state natural condition, or color return to red, which is how oxygen molecules are created. The process of light reaction in the first stage of photosynthesis is the light reaction, in which solar energy is transformed into chemical energy in form of ATP and NADPH. Protein complex and pigment molecules both contribute to a synthesis of NADPH and ATP. As a result, the light response in the tachyloid, or the equation above summarized, detonates of water and sun is one of the reactants, and products are oxygen, ATP, and NADPH. The light reaction traps the energy from the sun and converts into a chemical energy that is stored into NADPH and ATP. Oxygen is released as the waste product. The process of Calvin cycle, unlike the citric acid cycle, Krebs cycle, it is a catabolic. Then the Calvin cycle is an anabolic, which means building of an organic molecules from smaller components requiring energy to do so. The Calvin cycle is organized into three basic stages: the fixation, the reduction, and the regeneration. The Calvin cycle refers to the light-independent reactions in the photosynthesis that take place in the three key steps. Although the Calvin cycle is not directly dependent on light, it is indirectly dependent on light since the necessary energy carries ATP and NADPH are products of light-dependent reactions. In fixation, the first stage of Calvin cycle, light-independent reaction are initiated to carbon dioxide is fixed from an inorganic to an organic molecule. In the second stage, ATP and NADPH are used to reduce 3-PGA into 3GP. Then ATP and NADPH are converted to ADP and NADP plus respectively. In the last stage of Calvin cycle, RUBP is regenerated, which enables the system to prepare for more carbon dioxide to be fixed. So to summarize, photosynthesis occur into two phases. In the light reaction, light and water go in and oxygen comes out, as well as the ATP and NADPH that are used in the Calvin cycle, where carbon dioxide comes in and organic products like sugar come out. In this way, photosynthesis is similar to cellular respiration. Both processes rely on the succession of redox reaction in which electrons simplify flow in opposite directions. Sugar is produced during the photosynthesis, but sugar is destroyed during the cellular respiration or breakdown. Light-dependent reaction has three products. The goal of the light-dependent reaction of photosynthesis is to collect energy from the sun and break down water molecules to produce ATP and NADPH. These two energy storing molecules are then used in the light-dependent reaction. As we can see in the first picture, the product of light-dependent reactions shows these following products. On the other hand, the light-dependent cycles are use store chemical energy from light-dependent reaction to fix carbon dioxide and create a product that can be converted into glucose. The ultimate goals of the light-independent reaction or Calvin cycle is to assemble a molecule of glucose. As we can see in the product of light-independent reaction shows a sugar and glucose. In general, all by the products of light-dependent reaction and independent reaction are reactions are connected.